Menu with a Mission is a problem-based learning, or PBL unit, designed to help students build conceptual understanding of rational numbers. Student groups explore the relationships among fractions, decimals, and percents as they answer the project's driving question: is it possible to eat a healthy diet at my favorite restaurant based on the government's Choose My Plate nutrition guidelines? Throughout my years teaching middle school, one of the issues that continues to surface is that students struggle with converting between fractions, decimals, and percents. Whether it was during my time as an 8th grade teacher or now as I'm teaching 6th grade, I have seen the students forget the process or apply the wrong procedure to converting. Because understanding rational numbers, including the relationships that exist among them, is foundational to the rest of the mathematics students will use in school and in life, I chose to research and develop a unit that could help students not only learn how to convert among the different representations, but also understand the relationships. Fractions are usually introduced in elementary school, but the foundation is built during the middle school years. Although teachers realize the importance of building the conceptual understanding, students don't expect math to make sense, so they try to memorize algorithms instead of making conceptual connections. Several misconceptions exist that make it difficult for students to understand, mainly because they see no connection between fractions, decimals, and percents. The most common is applying rules for whole numbers to fractions and rational numbers. For example, when comparing fractions to determine which is greater, many times the fraction with the greatest denominator is chosen, with no consideration for the value of the numerator. Another example is seen when students compare decimal numbers. Many try to apply the idea that the number with the most digits is the larger number, rather than using the understanding of place value to determine which number is largest. Research shows that several key ideas should be included in the development of concepts. The use of number lines allows the student to see the connection between the fraction and decimal equivalents. This also helps them to see and understand the idea of a unit, which is necessary to grasp in dealing with fractions. Use of the division algorithm to change fractions to decimals is sometimes necessary. However, many times teachers show students how to use this method without giving the reasoning behind the procedure. Using correct terminology and mathematical language and collaboration among peers is invaluable. Everyday language in the explanation of a concept can help build understanding, but educators must be careful to avoid giving students the wrong impression with the words that are chosen. Talking about math and learning how to use mathematical argumentation helps students build understanding as well. The use of manipulatives is an important element in developing concepts. They help students move from concrete to abstract. They also allow numerous ways to represent fractions, decimals, and percents. Use of a 10 by 10 grid is very helpful. Because there are 100 squares, it lends itself nicely to representing the percent, decimal, and fraction form of a value all in one picture. When teachers design instruction for rational numbers, typically fractions are taught first, followed by decimals and then percents. However, research has been done that indicates that starting with decimals or percents is equally as effective. In fact, some recommend starting with percents because common percents, such as 50% and 25%, are amounts that students can easily connect to the equivalent fraction values of 1/2 and 1/4. Percents are also something that students see on a daily basis, in items such as the bar with an increasing percent value that is displayed as an item is downloading onto a computer. The National Council of Teachers of Mathematics, in its problem-solving research brief dated April 2010, emphasized the role of problem-solving in learning mathematics. As well, it has now become a priority to help all learners develop the 4 C's: critical thinking, creativity, collaboration, and communication, in order to function effectively in the 21st century. Problem-based learning, or PBL, provides the ideal framework to accomplish these goals. Groups of students are given a driving question which should connect to a real-world problem. Students work together as they solve the problem. Rather than the instruction being primarily teacher-driven, the students drive the learning. Although the teacher is more of a facilitator throughout this process, inserting direct instruction at times throughout the process is necessary to adequately help the students learn how to do the actual procedures. This project was implemented over a 4-week period with all 6 of my 6th grade math classes in an urban middle school in North Texas. Approximately 1/3 of my campus is on free or reduced lunches. This project was designed using a problem-based learning framework to answer the driving question, is it possible to eat a balanced diet at my favorite restaurant, based on the Choose My Plate guidelines? The material was divided into 3 main topics: converting from fractions to decimals, converting from decimals to fractions, and converting back and forth between decimals and percents. For each topic, I designed a set of clue cards and a decoder book that the student groups worked through to complete the learning. Groups chose which topic they wanted to start exploring. Upon completion of one topic, the group chose the next topic. They completed that set of cards and then moved to the third topic, which completed the process. Upon completion of all 3 topics, each group created a short video to summarize what they had learned. Throughout the lessons, several forms of technology were used, such as iPads, computers, and quick response, or QR codes. I also inserted different mini-direct teach sessions that either shared new knowledge or reinforced knowledge that students had been learning. For example, on one day, we used chocolate bars and 10 student volunteers to illustrate the idea that a fraction is another way to write a division problem. My introduction of Menu with a Mission began with 2 videos, a short clip from a news program that discussed the Choose My Plate food guidelines, and a minute-long video that I created to introduce the project to the students. A class discussion on the representation of the picture of the Choose My Plate took place, in which we determined approximate percent values for each category in the picture. These categories include grains, vegetables, fruits, protein, and dairy. Students were then placed in groups. Because this project was put into place the 2nd week of school, I had to rely on student profile information in order to try to create heterogeneous groups that contained a mix of higher performing and lower performing students, along with variations of special education students and English as a second language learners. For the most part, the groups seemed to be good combinations, although there were 2 or 3 students that I had to rearrange because of personality conflicts. Student groups first agreed upon the restaurant that they were going to use, and then completed a 2-day meal plan using only the items offered from that restaurant. This meal plan was then used throughout the project as they progressed through the clue cards and decoder books. Groups used numbers of servings for each category and total number of servings for their meal plan in order to help learn how to convert between fractions, decimals, and percents. Activities included watching short videos, using manipulatives, concrete and virtual, posting replies to blog questions, or working on short assignments. Because our district has set up Google Drive for use by all students in our district, groups were able to create a folder for information gathered that allowed access to the group members and me. This proved to be an effective way for students to easily organize information for their groups. Data for this activity was gathered in several different ways. Student replies on activities in the decoder books were used as checkpoints to determine if they were gaining understanding. They also allowed me to address, in a timely manner, mistakes that students were making. The form of data that I relied on to determine the success of this project was results from district assessments that took place throughout the year. The first table displays the information for questions that dealt with fractions, decimals, and percents from the first district common assessment taken in October of 2013. The question number, type of representation used in the question, and the percentage of my students who answered the question are given. When looking at the overall percentages from each problem, it seems to indicate that a majority of the students were able to correctly solve problems involving these skills. This second table shows the same type of information for these types of questions that appeared in our second district common assessment. Again, these scores indicate that a majority of my students still seem to be retaining the information that they learned from the unit. This test was taken in November of 2013. The 49% correct on question 17 caused me a little concern. However, when I asked the students about their responses, they indicated that the format of the question with mixed numbers and decimals was confusing. I used that to adjust practice questions to include more variations. The third table contains the information concerning my students from the district benchmark given in February of 2014. The data seems to indicate consistency in student proficiency with those types of questions. I was particularly interested to see that 70% of my students answered question 48 correctly. Because this involved application of the ideas to a different type of problem, it seems to demonstrate that student understanding is present for a majority of the students. Another type of data that I used in assessing this project was qualitative data from individual student interviews. I used a mix of male and female from different ability levels. They were asked questions that related to the appeal of the project and what their recommendations were for future implementation. Each student expressed the idea that using the menu idea and connecting to nutrition helped them to learn how to do the math while reinforcing the idea of living a healthy lifestyle. This table shows a sampling of the student responses that I took during that student survey. Research on problem-based learning indicates that the use of a real-world problem setting enhances student engagement and promotes learning. Student responses to questions about the PBL portion seem to line up with the research. After utilizing the items suggested from research, and after looking at the data from this activity, the results seem to confirm what the research suggests. A majority of the students not only enjoyed the format, but also demonstrated a conceptual understanding and an ability to solve problems connecting various representations of rational numbers together. Because the data was taken over an extended period of time, the results also seem to indicate that retention of the concepts has also occurred. This project connected to 3 different themes seen in the professional seminars. It integrated technology in multiple ways, using iPads and computers, Google Drive, and the QR codes that are scanned to take the students to the next step of their journey, allowing a different type of instruction. As well, students creating summary videos allowed them to learn how to share with others in a creative way. Equity in the classroom was reinforced by the group design in this project, along with the various modes of instruction that took place. The collaborative element allowed the students to learn how to communicate with others while appreciating the input of their classmates. Research and assessment were valuable tools in the evaluation component of this project. Purposeful planning of the types of assessments and questions provided an effective way to determine what the students understood and what still needed attention. The information I learned from this project has been invaluable. Not only did the research help me design a unit that appears to have promoted more consistent conceptual learning about rational numbers, I also learned several other skills that I have already begun to apply in my daily instruction. The value of using multiple representations for any concept allows students to learn how to see items from different perspectives. Using the group concept taught me how to encourage all group members to participate, while teaching others how to respect the thoughts of others. As well, teaching students how to talk about math revealed how much it supports their understanding of the concepts. Another priceless lesson that I learned from this project is how to research an area that students struggle with and then form effective lessons based on that research. My teaching will never be the same. If I were to offer suggestions to others on non-negotiable elements to include in instruction dealing with rational numbers, I would say that multiple representations, including number lines, 10 by 10 grids, and manipulatives must be included. As well, teaching algorithms without first discussing the rationale cannot be done. Students must know why first. After this experience with problem-based learning, I would suggest that teachers find a way to create lessons that allow students to explore and learn in this format. Although it cannot be done with every skill, there are many that can be learned this way. In doing so, the students will be engaged while the teacher creates learning that will change the lives of those students forever.